Yeah, good morning my dear students. Today I am going to discuss the topic on chromatography. What is the meaning of chromatography? Chromatography, chroma means color and graphy means writing, right? Chromatography refers the term of color writing and it is a word coined by a scientist called Svet. The Russian scientist who invented or who coined the term chromatography, and the technique is basically used for the separation and analysis of the components from the mixture, right? If you see this thing, it is a technique used for separation, analysis and purification of component from the mixture, right? Not only separation, analysis also, right? So chromatography is a technique used for separation, analysis and purification of the components from the mixture. So when you want to individual component, if a mixture contains 3 components, if you want to individually separate them, if you want to analyze them and if you want to purify them, then we are using ultimate tool as chromatography. And this chromatography requires 2 important phases. One is the stationary phase and the other one is the mobile phase, right? So stationary phase will not be moving, right? It is basically an immobile one, whereas the mobile phase is a moving phase, right? So what is the separation principle? How the components can be separated using this chromatography, either with the help of adsorption or with the help of partition. These are the 2 important principles underlying the particularly any chromatographic separation. One is adsorption, another one is partition. Now what is this adsorption? What is this partition? When I want to discuss this adsorption and partition, basically adsorption, if I have 2 components, if out of the 2 components, if one component is having a particular affinity towards the stationary phase, if one component is having more affinity or more binding with the stationary phase, it travels slower and comes out last. Basically, the elution of the compound will be very, very slow, right? Whereas if the component is having lesser affinity towards the stationary phase or lesser binding towards the stationary phase, then the component will be moving faster and eluted or comes out first. And no 2 components will have the same affinity towards the stationary phase and the mobile phase, right? This is also one of the important aspect, one should keep it in mind, right? Now coming to the another principle of partition is another separation principle. What is this partition says? Partition means between 2 immiscible solvents, right? Basically if you are separating between 2 immiscible solvents, then we use the phenomena called partition. So partition is a concentration, distribution. The partition is also defined by partition coefficient or distribution coefficient. That is concentration of the sample in the organic layer divided by concentration of sample in the aqueous layer. That is called partition coefficient. Now, if you have the 2 components, if one component is having more affinity or more solubility in the mobile phase, that compound will be traveling faster and comes out first. Because mobile phase will carry the sample. It is having the movement, right? So, if the component is having more affinity towards the mobile phase or more solubility in the mobile phase, it will travel faster and eluted or comes out first. Whereas the component which is having lesser affinity towards the mobile phase or lesser solubility in the mobile phase, they will travel slower and comes out last. So no 2 components will have the same affinity towards the stationary phase as well as towards the mobile phase. And this is the basic principle of chromatography. Either adsorption or partition. Any one of the principle will be holding the particular technique of chromatography, right? Now next important aspect what we are going to discuss is what are all the critical defining properties of chromatographic process? What are all the various critical defining properties to carry out the chromatographic process? Immiscible stationary and the mobile phases. The first important criteria is immiscible stationary phase and the mobile phase. The second thing, an arrangement whereby the mixture is deposited at one end of the stationary phase, right? The third important critical defining property is the flow of the mobile phase towards the other end of the stationary phase. As I told already, stationary phase and mobile phase are very, very important in any chromatographic technique. So therefore these 2 are very important things, right? And the fourth important critical property or the definition of chromatographic parameters, different rates or ratios of partitioning of each component of the mixture and many cycles of this process during elution. The last important critical defining properties of any chromatographic process is a means of visualizing the bands or zones of separated components on or adjacent to stationary phase, or of detecting the eluting bands as peaks in the mobile phase effluent. That means finally you have to visualize the bands after the separation of the particular component using this chromatographic technique, right? So these are all the 5 important critical defining properties to be carried out for any chromatographic process, whether it is a thin layer chromatography or paper chromatography or gas liquid chromatography or high performance liquid chromatography. Any chromatography, this critical properties are very, very important, right? Now already we discussed about adsorption and partition. Let us give one example for adsorption, one example for partition chromatography based upon the principle. Now this adsorption chromatography, the example is thin layer chromatography. In thin layer chromatography, we have the 2 phases. One is the stationary phase, another one is the mobile phase. The stationary phase is the plate, silica gel plate. The glass plate which is coated with the silica gel. That is the stationary phase here, right? Basically, the stationary phase what we are using in TLC, most of the thin layer chromatographic plate is silica gel G. Whereas G stands for gypsum, which is a binding agent, calcium sulfate, right? So silica gel plus gypsum, right, with the binding agent, and this silica gel will be poured over the TLC plate by different techniques. So this silica gel will be attached on the plate throughout the plate, right? That acts as a stationary phase. They are not moving here and there, right? Now the another important thing is that mobile phase is required. What is a mobile phase? Mobile phase is solvent. Basically the solvent, when you want to run the chromatography, we are just immersing the plate. We just take the plate is coated with the stationary phase silica gel G. In the plate you have to put the spot of the component. If you have 2 components to get separated, you put first component, then you put second component here, right? Or you put together as a mixture of components, you put together as a single component as such, right? So what will happen, these components, after spotting the components with the help of the capillary tube, then you have to put the plate in the solvent chamber. That is your development tank where we are putting the mobile phase as a solvent. So the mobile phase runs through the plate by ascending gravity as such, right? So what will happen, when they are running, the mobile phase will carry the spot forward here. Okay. So this is what we should remember here. So I am spotting 2 components, one here and another one component here. So when I compare here, the component 1 is having more affinity towards the silica gel, because throughout the plate silica gel is coated. So the component 1 will be binding with the silica gel G. Silica G is a binding agent. So the component 1 is having more affinity with the silica gel G. So they will bind with the silica gel G. Therefore what will happen? The movement will be restricted. So they will travel in a very slow manner. Whereas the second component is having lesser affinity towards the silica gel G. So what will happen? They will not bind much. So they will be traveling faster and comes out first. So this is the basic separation technique of thin layer chromatography using the principle of adsorption. I hope it is clear, right? So this is a very important aspect, and mostly the mobile phase is the mixture of organic solvents we are basically using. Sometimes we can use aqueous solvents also. Now example for partition. There is another example for partition, that is gas chromatography. So partition taking place in 2 immiscible liquids, right? So here what we are doing, we are taking 2 components. We have the 2 components, we want to separate them by partition. How it is possible? The stationary phase in gas chromatography is a non-volatile liquid, right? It is a non-volatile liquid supported on an inert solid particle packed in metal column. Basically in metal column we are packing this thing, so it contains the non-volatile liquid supported on inert solid particles which is packed in the metal column, just acts as the stationary phase. Right? Stationary phase is a non-volatile liquid. Now coming to the mobile phase is an inert gas as the mobile phase flowing through the column from the pressurized tank. When we are using the gas, we have to use the proper pressure rate also. That means the flow rate of the gas is very, very important. The high pressure or low pressure, what pressure we are using, that is also very, very important. So whenever we use the mobile phase, the inert gas as the mobile phase which is flowing through the column from the pressurized tank. So stationary phase is liquid and the mobile phase is gas, and they will not miscible with each other. Definitely both of them are immiscible with each other, and there lies the principle of partition. Based upon this partition phenomena, how your components will be traveling within this stationary phase and the mobile phase, and how they will get separated. So that is the basic principle of any partition chromatography, basically the gas liquid chromatography, right? So various partition ratios between the phases, right? The various partition ratios between the phases. So if you have two components, what are all the various partition ratios between the phases, right? They will affect the separation process, and primarily related to the components different volatilities. How the sample, see, most of the gas chromatography, the sample component is also volatile or semi-volatile in nature. So therefore, depending upon their volatility, which component will be moving faster, which component will be moving slower, accordingly we can separate them, right? So based upon the different volatilities, components different volatilities, nothing but boiling point. One of the example is boiling point, right? So based on that, we can easily separate the two components. One component will be moving little faster as compared with the other component. Most of the time we are able to separating the hydrocarbons or any petroleum ether or such type of solvents we use to separate them in a very, very easy manner. Right? So any components, basically the volatile or semi-volatile components either present in the synthetic nature or in the plant components can be separated with the help of gas liquid chromatography, and the principle used is partition technique. Right? Whereas in thin layer chromatography, the principle is adsorption. So that is a different aspect, right? So this is the basic principle of chromatography as such. I hope the students will understand in a better manner. So thank you very much, my dear students. Thank you very much.